Okay, so let's take a look at the odd-numbered questions. So I'm going to first find f prime of x. I feel like this is really thick. Okay. Which is cosine x minus sine of x. And I'm going to set this equal to 0. So then I want to know when sine of x is equal to cosine of x, which is from advanced math. And essentially what I want to do is I'm looking at quadrants. So they are the same when they both are 45 degrees. And so in quadrant 1, x is pi over 4. And then they're also the same when they're both negative, which is in quadrant 3. So that is 5 pi over 4. And then I am between 0 and 2 pi, so that's fine. So I've got interval, test value, sine of f prime of x, and then conclusion. And then I'm going from 0 to pi over 4. And then I'm going from pi over 4 to 5 pi over 4. And then I'm going from 5 pi over 4. Oops, not over 2. To 2 pi. Can make a bigger square bracket there. Okay. And I'm picking values, so like pi over 6, pi, and then 5 pi over 4 is in quadrant 3, so like 3 pi over 2. Okay, so now f is pi over 6. So again, no shame in drawing a triangle. So now when I do this, pi over 6 is the same thing as 30 degrees. So I want cosine of 30, which is root 3 over 2, and then minus 1/2. So that's going to be bigger than 0. And then f prime of pi, so cosine of pi is negative 1, and then 0, so this is less than 0. And then 3 pi over 2, cosine of 3 pi over 2 is 0, and then the sine of 3 pi over 2 is negative 1, but that's negative, so then that's a bigger than 0. So f is increasing. F is decreasing. And then f is increasing. And then to find my relative extrema, so I'm going from increasing to decreasing, so that's a max. It'll be a relative max, and then decreasing and increasing will be a min. So now I want to find out what f of pi over 4 is, and I want to find out what f of 5 pi over 4 is. So then this is root 2 over 2 plus root 2 over 2, which gives me root 2. And then 5 pi over 4 will give me a negative root 2 over 2 minus root 2 over 2, which gives me a negative root 2. So f is increasing. On the interval from 0 to pi over 4, union 5 pi over 4 to 2 pi. And then f is decreasing on pi over 4 to 5 pi over 4. And then f has a relative minimum at 5 pi over 4 comma negative root 2. And then f has a relative maximum at pi over 4 comma root 2. Okay, so now we're going to go ahead and look at the next one. These are a little longer. So this is where everybody gets a little confused. So if I were to do f prime of x here, this is going to be a product rule. So it's x minus 4 squared times 2 times x minus 2. And then this is plus x minus 2, the quantity squared, times 2 times x minus 4. Now, your first initial thought is to multiply all this out, and that would be wrong. There's a reason why we did this thing in advanced math where we factor out the greatest common factor. It's because you would do it here. So I'm going to factor out a 2, I'm going to factor out an x minus 2, and I'm going to factor out an x minus 4. And then what I'm left with is an x minus 4, and I'm also left with a plus x minus 2. So now I have 0 is equal to 2 times x minus 2, x minus 4, and then this gives me 2x minus 6, which is the same thing as 0 is equal to 4. Factor out a 2. And then I have an x minus 3. Okay, so now I get x is equal to 2, 3, and 4. So now my interval, test value, sign of f prime, and then conclusion. So now I have no interval. So I'm going from negative infinity to 2, and then I'm going from 2 to 3, and then I'm going from 3 to 4. 3 to 4. And then I'm going to 4 to infinity. Okay, so I want x is equal to 0, x is equal to 2.5, which is, 5 halves. And then I want 3.5, which is 7 halves, and then 5. Okay, so when I plug in 0, I get a negative. So f prime is less than 0. When I plug in 5 halves, I get bigger than 0 to less than 0. So this is going to be bigger than 0. And then I plug in 7 halves, and I'll get 2 of them to be bigger than 0 and 1 to be less than 0. And then when I plug in 5, I get bigger than 0. So f is decreasing. F is increasing. F is decreasing. And f is increasing. So that means I go here, there's a min, here is a max, and then here is another min. Okay, so now I want to find f of 2, which gives me 0. Then I want to find f of 3, which is going to give me 1. And then f of 4, which is also 0. So f is increasing on the interval from 2 to 3, union 4 to infinity. F is decreasing on negative infinity to 2, union 3 to 4. F has a relative minimum at 2, 0. Oh my goodness. And 4, 0. And then f has a relative max at 3, 1. Okay. And now we're going to go to 5. We're only looking for... Oh, I didn't want you to do 4 and 5. Sorry, 5 and 6. So, because it talks about absolutes, which is not part of this lesson. So that's it for all the odd numbered questions.